All right, good morning, good afternoon, folks, depending on what part of the world you're in. This is the antenna selection for real-world applications webinar. And your hosts today include Joe beside me. He's captain at the helm of Starship SensThys. I really wish I hadn't used that analogy because I'm not sure how VP of Sales and Marketing fits into a Starship. My name's Neil Mitchell. So without further ado, let's jump in and get this started. Just a couple of slides to set the scene. Some of you who have attended previous webinars may see a couple of similar slides before, but we'll get past these and get on to the core. But the problem really is with RFID is that really this is all about the data. And there's an incredible amount of data available. It's really fun. It's sexy. There's a lot of stuff we can do with this data.
So it's an easy way to get a startup funded is you do big data in the cloud and crap like that. But the reality is that the systems that collect this data, they sort of are, they're not very sexy to work on. They're hard to get funded, and they're kind of kludgy a lot of times.
Yep, and also the economics is just appalling when it comes to the actual hardware that goes into these systems, particularly at scale. It's just not particularly economical, and that's obviously some of the things we're trying to address here at SensThys. And also the actual use of RFID is not particularly practical because it's very complex. The software interfaces can sometimes add complexities as well. And if you step back and take a look at problems that we're all trying to solve in this industry, we are trying to solve problems. We're not trying to just throw technology into a problem.
Right.
And the challenge today is there's a lot of people trying to take a round peg and bang it into a square hole. And so everyone tries to solve a problem with RFID and doesn't look at other sensors as part of that potential solution. So we're a believer in multiple sensors working together in cooperation, including RFID. RFID is definitely one of those sensors, but it will often, more than not, work together with other sensors in the system.
Right.
So the solution really is to take a look at how to make sensor platforms and RFID as simple as possible. How do we remove the challenges of configuration and installation complexity? How do we make it easy to manage these systems and connect these things up and get them working as quickly as possible? And at the same time, we've got to make these things very, very economical. You know, we all in the industry have now tags down at a few cents, 3 cents, 4 cents, 5 cents, but we really don't have the economics of the hardware where it needs to be for RFID to take off, and that's what we're driving to here.
And it's interesting when we talk about economics, you're going to see when we talk about antennas, which is really the main talk here, is that it's pretty easy to mess up an RFID signal unless you can have multiple sensors, multiple RFID sensors looking at the same area. So for us, economics is sort of a backwards way of getting into a more robust system.
Right, right. Also, the aesthetics are quite often overlooked by others in the RFID industry.
No, really?
Really, absolutely.
It's good-looking gear, baby.
And we wanted to make these things blend into the environment in which they're going into, whether it's commercial environment or a manufacturing environment. We want them to be slim, low profile. We want them to kind of blend into that environment. And sure, maybe if it's inside a portal, maybe it doesn't quite matter quite so much what it looks like. It probably matters the form factor. But it does matter what it looks like in many applications. So we've also taken a look at how to address that. So we can dress our readers up in clothes. We have material covers we can put on them.
We've also silk printed logos. One bid we did for a children's store included putting things like dragons and clouds and rainbows onto these things so that when they looked at them, they were fun to see. Anyway.
Yeah. So if you take a step back, and what SensThys is trying to do here is to provide a number of sensors that you can see, for example, at the bottom of the screen here. So So provide these types of sensors and many more. And we also want to provide a very inexpensive, foolproof infrastructure to providing both power and data management. And I want to emphasize the power as much as the data. So we're about power delivery as much as we are about data delivery. What we don't do is we don't do the enterprise intelligence. We leave that to our customers, our value-added resellers, our partners.
And all these fancy startups.
And all these fancy startups. But what we do is that data power management and providing the baseline sensors. So the first of those is the CenterA and CenterA Plus. And here you'll see us, again, talking about this simplicity, the economics, and the aesthetics. And this is something we keep talking about and believe in. So the CenterA combines an antenna, full power reader. It combines the network switch for data, but it also combines in the power distribution so you can connect these things together and effectively plug them in together like Lego bricks. So we have a CenterA, which has 2 Ethernet ports for power and data in and out. And we have a CenterA Plus, which has 3 Ethernet ports, so data and power coming in and out on 3 ports. And SMA connections for 3 additional antenna, so 4 antenna in total, and GPIO as well. This device is designed and built in the USA, so if that's important to your business, it is. So taking a look at how these things are linked together, the CenterA and CenterA Pluses can be literally just data chained or networked together with a simple Ethernet cable transferring power and data between each. And then CenterA Plus can have a RF antenna, or any antenna hooked up to them with via an SMA connector. And then we also have, because we're PoE, we can connect all kinds of other PoE peripherals and devices. And the example we show here is a PoE camera, where we can actually be pumping video through multiple CenterAs back to wherever the PC or server happens to be.
Right, or the cloud.
Or the cloud. So that's the basic concepts. We recently introduced a brand new antenna called the SensRF 101. And this the kind of design mandate for this guy was really to meet or beat the kind of industry standard LED type antenna, but just do it at a different price point. And so we've actually succeeded in that. All the testing we've done is showing that we do indeed meet this performance, so kind of LED type performance. We do it as an IP68 package, better than some of our competition, and we will be going and doing a lot more testing on this. For example, we'll be doing full mil-spec testing and some other testing as well, of course. It is available in flush or Visa mounts. The Visa mount is 100 millimeter studs on the back. But the big thing about this is the economics. The single unit list price of this antenna is $49. So, of course, in volume, that price goes down.
Right, and a couple things to say. One is, if you guys have ever taken apart a lot of the antennas, there's really not that much to them. And what we're paying for in this industry is a fairly complex distribution model. And we really want to support folks getting a lot of read points out, support people that are driving to give their customers a lot of read capability. And that's the third antenna we've designed. And a couple things, there's a fair amount of pride that we have in these things. We've been invited to talk to RF design conferences on some of the designs that we've done. This is, again, the third. It's a little bit shorter than layer, but in all practical aspects, it's a good broadband antenna, fine VSWR, really good far field. Our supply chain, we have been very sensitive to the fact that we want to maintain a very direct sales channel to you, number one, and number two, we wanted to make sure that we had a supply chain in place that we frankly don't know where the tariffs around the world are going to go. That's been rippling through our supply chains. This antenna is being built in a way that, if trade wars happen between the United States and China, you're not going to see this price move around very much at all. Where the other side of the supply chain, I think, is actually pretty vulnerable because most of these antennas are made in China. Last thing that we'll say here, and then we'll really try and talk to you about the physics of the antennas and how to think about them maybe a little bit more clearly. We helped design the Times 7 5010, and one of the things that we learned in doing that is that when you talk to folks in the industry, quite often there's some need for technical assistance, and sometimes it's actually reasonably subtle. And Times 7 was fortunate enough to be the antenna supplier into that huge Delta project, and the reason that business was won actually had to do with some very, very interesting technical details about how do antennas like the layered antenna function in situations where metal's very, very close to them. And layered makes a great antenna. We really have a lot of respect for those antennas. But that architecture behaves differently than the architecture of the 5010. And the 5010, while it doesn't read as many tags or requires a little bit more power to read tags, does great with reflection. The main point here is there's somebody you can call here and you can talk about technical issues with antennas. And I'll really, I think one of the interesting things about our industry is on the reader side somewhat, on the antenna side in spades, it's really hard to get any technical dialogue with anybody that designs an antenna. And that's something that we take a lot of pride in. You can call us up and we'll really help you through things.
Yep, because the guys that design the antenna, we can answer the technical questions. So lastly on the aesthetics as well on the antenna, so it's actually a very similar form factor, almost identical to the form factor of the CenterA, so it won't look dissimilar. So again, it helps on the aesthetic side of things. And just like the CenterA, you know, we can still screen this with your favorite logos, your favorite unicorns, fluffy clouds, whatever you like, or just leave it plain. Basic specifications here of the antennas. We'll do a quick comparison here. I won't go into all the gory details, but let you kind of peruse this offline. But you can see here on the far right the SensRF 101. This is our new antenna. So you can see from the specs here, just scanning down on that, it's very, very similar indeed to the layered on the far left-hand side, other than, of course, the cost, which is about 1/3 of the cost. We're also we can also provide the Times 7A 5010. We brand that as the SensRF 10. That's about $115 from SensThys. Right. So let's have a quick look at the comparison between the layered antenna and the SensRF 101. And you can see here basically that the performance is pretty much identical on, you can see it on the right-hand side.
Yeah, so a little backstory on this. We really enjoy technical dialogue with our customers, and those of you that have worked with us can appreciate that. We had a customer, really good guy, Chad Slining of Invotech, and he put us in direct competition with an R420. And we lost. And so after we licked our wounds, we went back and really developed a whole set of methodologies for digging into how to quantify our performance and how to really figure out how we stack up against, benchmark ourselves against everybody. And on our next webinars, we'll show you a lot of benchmark data between our enterprise reader and everybody else out there, and really proud of the progress the team made here on that work. But the main test vehicle is what we call a CHAD roll, and behind that is a tag board. And so there's a little bit over 700 tags, 6 different tag types. There's a lot of different polarizations, a lot of tags that are screening each other. It's really difficult for readers and antennas to function in this. And this is basically where this data comes from. And you can see that the blue and the gray, which you can't see actually is distinct, are our new antenna versus a layered 9028. You do notice that the SensRF 10, which is the Times 7 antenna, the curve looks very similar, but it requires a little bit more power to drive that antenna because of the physics of the antenna. But long story short, we're basically layered antenna performance is what you see out of the 101.
Yep. If you have an application where you really do have very high reflective, a lot of metals around, of course, a lot of reflections, certainly taking a look at the SensThys RF10 is probably something you do want to take a look at. Costs you a little bit more for that, but and of course costs you not just in terms of dollars, but also you're losing about 1.5 dB of power getting through the antenna. But it may suit your application more. But for other applications, the layer type antenna and the SensThys RF101 is the way to go.
Yep.
Half the price or third of the price.
Third of the price. We had this discussion yesterday, Neil.
We did. All right, so let's go off and we'll take a look at the use of multiple antenna now. And this is where I think the webinar kind of gets a little bit more interesting than many other webinars that you may have seen before that talk about antenna. So if we take a look at the way traditionally, let's say in the industry, that organizations use multiple antenna, particularly when they're trying to flood an area and cover a large area, you might see a situation like you see on the screen here, with multiple antenna, and effectively what you're seeing is each antenna basically is only seeing a tag once. And so if someone comes along or something comes along and gets in between your tag and any particular antenna, RFID antenna, you are going to block that tag, and you will no longer see that tag. And clearly that's going to cause problems for visibility. But there's other reasons for tags becoming invisible.
Yeah, one of the things that we, as a company, really want to do is to help represent a realistic version of what we can and can't do. And tags can be, you can have a polarization problem. You can have a frequency null because somebody moved a metal rack and it interferes with the antenna pattern. So there's a lot of things that can trip up an RFID system, and you'll hear somebody say, well, I have 12-meter read range. And the difficulty with that statement is you have to follow it by, with this tag in an unobstructed thing, blah, 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 blah. And I think what we're trying to help people understand or visualize in the next few slides are what are practical ways to sort of get around those problems and really start to have read rates in more challenging situations approach a much higher number.
Right. So we take a look at this particular view here we see here, but kind of multiply it up a little bit more. So here we've got fixed antenna now, and we've decided to kind of overlap the antenna coverage. And you can see here that in certain places, and I've numbered it on the diagram, so the numbers represent how many antenna actually see that particular area. So you can see on the outside, we still may only have one antenna covering a certain area, but now we have 2, 3, or 4 antenna actually covering certain areas within this overall coverage area. And we kind of drew the tag on there, and it cleared the tag there, depending on exactly where it is, you can see 2, 3, or 4 of the RFID antenna. So that's great. Let's multiply that up even further. And here we go.
So just so everybody knows, we've done this experiment, and the little guy that you see there is actually Neil on his hands and knees getting over the tag. And there's a wonderful picture of it that somehow didn't make its way into the.
I'm sure everyone will be very pleased to hear that photograph did not make it in, but yes, I was blocking the antenna. So here you can see if someone comes in, walks in between or something, whether it's metal or water-based object like a human being, comes in and blocks a tag. Here at least you've got more than one antenna that's able to see the tags.
Right. So
let's multiply that up. So you can see here, again, the coverage, same situation, just multiplied up to more antenna. So this is great. I mean, effectively, if you kind of mathematically take a look at the coverage, this is actually more of a square coverage per antenna rather than Yeah, but even though we're showing these as circles here. But the question here is, how do we improve this? There's still some areas here where there are only 2 antennae providing coverage, almost as little diamonds in some respects between each of the readers.
Right.
So we can actually address that very easily.
Oh, hey, just one moment.
Sure.
One of the things that, I'm sure that people on the other side are saying, yeah, well, duh, all we've done is we've moved our antennas to closer, and that's not all that sophisticated. And there's a fair amount of truth to that, but part of our response to that is kind of what we're trying to do here is to make these things so inexpensive that, of course, you put in a lot more read points. And so there's, you know, although to some extent when Neil shows that, you just say, well, it's closer. Of course, you can see better because you have more read points. We'd like to be the folks that really drive the economics of the industry so that more read points become easy to install and economic to install, and they become sort of the way that everybody does things.
Yeah, absolutely. So
the next point's more sophisticated, though.
Now we're starting to
a little bit.
A little bit. So if we take this now and effectively take every other row and shift it by half the distance between the 2 antennae above it. So effectively what we've done now is we've removed that little weak area where there was only 2 antenna coverage. So we effectively now have complete coverage within the circumference of these antennae of at least 3 read points.
Yeah.
In some cases 4 read points.
And again, this is a sort of visual simplification, but if you were to actually look at field strengths moving from a square symmetry to this called hexagonal close packed, makes the overall field much more uniform across this thing. So the visual representation is actually a really good representation of something that's also in the math domain.
Yep. Yep. Yeah, in some ways it's a digital representation of something which is very analog.
Yeah, right.
Yeah. So here we've got the 3 or 4 antenna being visible to every single tag. And then if we kind of just color code this to show that a little bit easier. So this is the area which is now covered by 2 or more antenna. So you can see basically it's completely within the circumference of this antenna array, with some lobes outside are being covered by 2 or more. And conversely, if we start looking at 3 or more antenna, then basically again it's anything within the circumference of these antenna. So if we now take a practical look at this and to try and prove this, in our office we actually have 4 antenna, one of which is actually embedded in the reader in the ceiling. And the central graph you see there, well, basically you can look at it almost like a hot point. It's a heat point, you could say, of the RF radiation. And so the hotter it's looking, the oranger it's looking, the more RF signal there is. And if we place a tag within those 4 antenna, clearly we can see it, we can read it, nothing's blocking it, it's great. And then, yes, Neil gets on the table and hides the tag, and trying to hide the tag from as many antenna as possible, and that's what you see on the right-hand side. And despite that, you're still seeing 2 antennas still actually seeing the tag. So that's kind of proof of the pudding that multiple antenna give you that visibility if you are going to be blocking tags, which of course is going to happen at some point in a large area. So let's take a look in a little bit more detail at how these individual antenna can be used in a particular environment. And one of the first things to consider is the gain of the antenna, and particularly how that relates to the height of the ceiling that you're installing the antenna into, or is the distance between the antenna and the tag. So clearly the tag could be on a table, it could be on some equipment or something off the floor. But in consideration, keeping this simple, what's the distance between the tag and the reader antenna? So in this case here, on the left-hand side, if we have an 8-foot ceiling, and we're showing that you can see on the left-hand side a 6 dBIC antenna, and the lower the gain, kind of the more bulbous the RF radiation coming out of the antenna is. And because it's going further left and right, it spreads it out further. It's not going to go as far either. And the higher the gain, the more you can think of this as a flashlight going further, so the beam's going further, but it's narrower. And so depending on your sitting height, you may actually find a lower power, a lower gain antenna might actually suit your application better, or maybe perhaps it's in the case on the left-hand side here, we're showing the 9 dBIC antenna as working out better for coverage.
And what we're going to kind of move to next is, so first, the reason that we put this in is to make sure that people understand that bigger gain isn't always better. It's sort of a Goldilocks thing where you're trying to find the gain that's right for the application. And there's a bunch of things that are sort of behind what those patterns look like in real life. One of them was what kind of antenna you use. Not antenna, what kind of tag you use. So if you're using a dog bone and you can see it 20 meters away, that leads you to very, very different conclusions than if you're using a tiny tag that mounts onto a metal object. And the same sort of ideas hold. 12 dBIC is better for longer, as a low gain antenna is better for closer. But the next thing we're going to walk you through is taking this and trying to put it into a real life calculator for you.
Right. So this is a little bit of an eye chart, but let's walk you through this from a high level. So this is actually going to be, well, it is a tool. This is a spreadsheet that we've already developed, and we'll be putting a version of this online. It's not online right yet, but over the next few weeks we'll work to get this up online, so anyone can go on it and plug in the data. The data you need to plug in is pretty simple. You go off, you take your tag that you intend to use on your application, you slap it on the product that you intend to have tagged, and in a perfect environment, you go away and you read it and you see how far you can read it from. What's the maximum read distance? Yeah,
and this calculator is based on you putting that onto like a layered 9 dBIC or a SensRF 101, so a standard 9 dBIC antenna. And then the calculator will do the rest from that. And then you exactly as Neil says, you take your tag on the thing you want to measure, you measure the maximum distance with a 9 dBIC antenna and the reader that you want to use. So this works with anybody's reader, not just ours. Then back to you, Neil.
Yeah, we then apply a derating factor, and this is really all about how much power is actually getting to the tag. And so we derate this, and you can put in your own numbers here, but for most of our calculations, we either use 66% or
even higher. So that means that you need 3 times the minimum power. So 66 is more derating, is more conservative than like a 10% derating. So that basically says you need 3 times that minimum power to feel good about seeing the tag.
Right. Then you plug in, and this is all in meters, by the way. So then you plug in the application read distance. How many read points do you want each tag to be seen by? So do you want 2 antenna, 3 antenna, or 4 antenna to see each tag? And then finally, you just plug in whether you want square or hexagonal configuration of the antenna. So that goes back to a couple of slides back where you saw either the non-row shifted or the shifted rows of the antennas. Once you plug those in, that's all the inputs are needed, and then it spits out the outputs for you, and it will tell you the best gain antenna for your application. It will tell you the area covered by each antenna, the radius, the X and Y spacing, because that's actually important, not just the area covered, but the actual spacing in X and Y. And it will also spit out a cost for you based on your CenterA and SensRF products. Clearly, if you're going to be using someone else's, that's going to be a higher number. Hence the spreadsheet. But it will spit out the cost, and you can see here in one of the calculations that we have $1.61 per square foot in this particular application. Do you want to talk about the?
Yeah, so a few things. A few things to comment. One is the cost per square foot. It is our gear, but that does include all the hardware. So that includes power supplies, it includes cabling, antennas, readers, the whole ball of wax. It doesn't include installation. Just so that you understand what we're talking about and what we're emitting if you need to bid a job. The top thing that's color coded, it shows you 3 different antennas, and on the top it shows the antenna to tag distance. And for this set of parameters, you can see that if you're at like 2 meters antenna to tag, you've got a 6 dBIC antenna that looks really good. At about 3 meters, you could use a 6, 4, and 9. Then 4 to 5 meters, you're sort of looking at a 9 dBIC and then transitioning to a 12. And then above that, of course, you see the 12 dBIC antenna being the best choice out there. And that's a real quick visualization tool that allows you to, once you kind of know the sensitivity of an antenna, of a tag on a piece of clothing or whatever it's on, that's a handy chart that tells you, okay, here's how far away I am, which antenna should I use. And full disclosure, we don't make a 6 and we don't make a 12 dBIC antenna, so this calculator will sometimes recommend things that we don't sell. We have tested 6 dBIC antennas and 12 dBIC antennas. More experience with 6. Time 7 makes a cute little a low gain antenna called the 5020, and later makes a really sweet little antenna. I can't remember its name, but both of those test well here. Then you can see some additional work in the bottom. One is just showing you normalized antenna patterns, and these antenna patterns are mathematical simplifications, but you can see that as you go to lower gain, the antennas spread out. And then at the far right, you'll see the coverage radius chart. And on the bottom, again, it's the distance between the tag and the read point. And then, of course, on the other side is the coverage distance. And so it's meant to give you a lot of practical information about what antenna is right in your situation, your reader, your tag. And this will be, we're going to get our intern putting this on the website for you guys. Right. And so you'll be able to click on your own data and use this as a tool.
Yeah, so, but very basically, you don't need to worry about the table at the top unless you really want to. You just plug in your inputs onto the input section and you look at the outputs, and that's what you need to worry about.
Yeah.
If you want to kind of take a look and say, well, you know, the 9 dBIC antenna in this example sounds good, but I've only got a 12 dBIC or whatever. You know, what would be the results if I use that? Then you can take a look, and depending on the gradation coloring in that table at the top, give you some idea of its goodness.
Yeah.
Just from a high level.
Yeah.
Okay. So what we've also done, and again, I won't go through this in detail, is we pulled out just a couple of examples, and yeah, as always, with the view of being as honest as possible, you want to take some of the extremes and show them here as well. So we took an example which potentially could be a little shelf read area, which is reading about 2 meter distance from between the tag and the read point. We only need a redundancy of 2 antenna and a hexagonal pattern. And then the spreadsheet you saw spit out there, about 11.5 by 9.8 feet coverage with a 6 dBIC antenna, and $1.93 per square feet. Then we've got some other examples there of commercial, where we have a 3 meter height, a retail environment with a 4 meter height, wanting free antenna coverage. We've got one example there with a 4 read point coverage, and even a warehouse with a huge 9 meter height, 30 feet height warehouse, wanting 3 antenna to cover each tag. So that's obviously going to be a bit more expensive. So the 12 dBIC antenna there, you'll get at a cost per square foot a cost per square foot of about $4 or so, versus less than $2 for something which is a shorter height ceiling. So another thing we did, and actually came out of this as we were doing a lot of testing, is we said to ourselves, well, okay, let's take this CHAD roll, this huge array of random tags with different tags and different orientations, and let's take a look at the read rates, and let's see how many tags we can read in with each antenna.
Yeah. So just one last point here. Most of our work, we will dial either the power down or the distance up, so that it's impossible for us to see all of the tags. Because, you know, as soon as you see 100 tags, if you see 100 tags once and you see 100 tags the next time, it's very difficult to compare which is better. So that's an interesting way for us to talk about things. So when you look at the tags here, this is a subset of the full CHAD test. And this is a roll of 5 different tags. And so you can see that we've biased this power level so that we're seeing on about 60% of the tags. And the real point here is every time a different antenna looks at that roll, even the antenna that's quite a ways away, it's picking up its own unique tags that nobody else can see.
Yeah. So the way to read this chart is we basically did 3 read attempts and counted up the number of unique tags we could read and then averaged that. That's the average line. So clearly you can see here at 4 antenna, we had 160%, so 60% more ability to read unique tags versus just a single antenna, despite nothing else changing in the environment whatsoever.
Mm-hmm.
So I think that's a very interesting data point. So, in conclusion, so we've taken a really look at, if you take a look at the way conventional readers and antenna are configured, I mean, they're pretty much guaranteed for failure because you are going to see blockage or something moving in between and blocking the RF between a tag and a read point at some point. So you're pretty much guaranteed to see some form of failure there.
Yeah, it's kind of interesting when we wrote that, we look at it as being a little bit of a harsh statement because obviously people are in this industry and they're doing good work. But quite often, a different way of saying that is if the hardware is so expensive that you can't really afford multiple viewpoints, that puts you in a very difficult situation and you're likely to miss things pretty often.
Right, right. So the overlapping read zones we've presented here really allows you to get what we call antenna diversity. So it really allows multiple read points to see each tag, which protects you from the failure point above. And it also makes your solution much more immune to tag orientation. And that's one of the things that I think we all see in our industry has been a big problem. Even if a tag is fairly close to antenna, it could be at an angle which is making it effectively invisible to that antenna. And because you've got multiple antenna now seeing each tag, even if a tag is turned with its knob facing the antenna, another one of the reader antenna will see that tag. And as we just shown you in the last slide, really having more antenna also has an additional ability to provide a larger number of unique tag reads in a set amount of time. So you get multiple benefits of this. And then again, if we go back to really the fundamentals of what we do here at SensThys and why we're doing things differently is, we're trying to make this a practical solution in terms of ROI, and that's why we're coming out with $49 antenna. That's why we come out with the SenterA at $689 list price one-off, for a reader with integrated antenna and power and data distribution. So I think you can see here that we really tried to show the best way to use multiple antenna in array coverage area, and we have introduced the tool, this aerial antenna coverage tool, and we'll get it up online sometime over the next few weeks. So just lastly, I just want to really hammer home. So we're all about trying to enable many low-cost read points. and make that as practical and simple to connect them and get them installed. That's what we're all about, and we believe that's the right way for the industry.
Oh yeah, sorry.
Yep. So just to finish off, if you need our contact information, it is right there. If you do have any questions, feel free to type them in, and we'll take a quick look and see if we have any interesting questions to go through.
Yeah, while people are putting in their questions, and when we talked about benchmarking readers and improving the efficacy of our reader, we're quite proud of the way our first reader performs. The 420 did beat it, but as we started to benchmark, we ended up benchmarking against 9 readers. I guess 6 of those we would call enterprise class readers. Learned a lot, and our next webinar is really going to talk about what we learned there and actually how does this little thing perform, and that is really cool data.
Yeah, we're really going to be opening kimono on reader performance, not just for our own reader, but also a lot of the mainline competition out there from the likes of Zebra, Impinj, Alien, etc. And so we're going into some
ST Micro, 5 chips. We're not going to, just so that we're sensitive to folks in the industry, we won't be naming who performed where, but we will show you by power what does a 33 dBm reader perform like, and how do we compare against those. What does the 31.5 dBm class look like? What does 30 look like? We got a question.
Yep. So the question is, with 4 antennae connected to a single reader, are all antenna reading simultaneously, or is one antenna on at a time?
They cycle through antennas. So if we set up one of our readers in sort of a standard inventory mode, it'll go through each antenna with sort of this intelligent algorithm, but just one antenna at a time.
Yep. Thanks, interesting presentation. Do you have an ETSI version, or is it FCC only at the moment?
It's broadband.
So the antenna is broadband, i.e. it's available for use in one SKU for FCC and ETSI. And the reader is currently on sale as FCC, and we will be coming out with an ETSI version of it within 3 to 4 months-ish, let's say.
Yeah, it'll be sooner than that, but we have to get the certification.
Right.
The next reader for us will be region assignable in the field. So you'll just say, where are you? And it'll dial in all of the operation. The antenna is good to go out of the box anywhere around the world.
Right. Any last questions? Otherwise, we're going to call that a day. Thank you very much for joining us, and we will be introducing some very interesting data in the next webinar that I think is going to be interesting to a few people in terms of performance.
Yeah, we find some
on it.
Yeah, we do. One of the things that we find funny is there's a beauty pageant. So how many times can you read the same damn tag in a second? I can read it 2,000 times a second. And that doesn't seem to be the right sort of metric. So one of the things that you'll see us talk about is, what do we think actually matters, and how do you measure that, and then how do these guys stack up there?
Yeah,
it'll be fun.
Just got one final question. So what is the best type of antenna for tolling applications? I think that's probably a longer conversation, because it probably depends on the type of tolling you're doing. If it's open road tolling, you may need some fairly specialized antenna to be pretty high gain to focus in on single lanes and things of that kind. Plus, you need to be completely robust to all weather types, environments, etc.
So yeah, so our introduction, the plastics do have UV inhibitors, so they're good to go outside. Antennas like this are used for some tolling applications, but for this, why don't you give us a call? We'd be happy to talk in detail, and we'll point you to an antenna that we don't make, or a type of antenna that we don't make if ours don't really suit your application.
Yep. All right, I think we're done. So thanks everyone, and we'll send an email out with our next webinar, and hopefully you'll be able to join that and learn some more from us.
Yeah, thanks everybody.
Thanks everyone. Bye-bye.